Graphing problem 2. Another graphing problem, but it's different. Why is it different? It's a velocity time graph. We have velocity plotted against time. So find the displacement and the acceleration of the object from 0 to 4 seconds and then 4 to 6 seconds. Two things we need to know about a velocity time graph. The displacement of the object is given by the area between the line and the x-axis. So let's just look from 0 to 4 seconds. Let me draw a little line here. This is the area we're talking about. That area gives us a displacement, which is delta x. The slope of a velocity versus time graph will tell us the acceleration. So acceleration is the slope, which is rise over run. And what's the rise? Well, it's delta v, velocity over time. And what's delta v over time? Well, that's acceleration. To solve for the displacement from 0 to 4 seconds, we'll look at the area between the line and the x-axis. So that is this piece right here, highlighted in yellow and now surrounded by purple ink. That's a triangle. The base of the triangle is 4 seconds. The height is 15 meters per second, so the area or the displacement is 30 meters. Now where did that come from? Here's the equation for the area of a triangle, 1/2 base times height. Here's the base, here's the height. And look how the units work out. We have seconds times meters per second. Seconds cancel and we're left with meters. So the area is 30 meters. So that is our displacement. Let's find the acceleration of the object between 0 and 4. So we need to find the slope of this line here. So the slope is rise over run, or the change in velocity over t, or the change in time. Either way you can write that. So our acceleration is going to be change in velocity, which is 15, right? It's 15 minus 0. And the time is 4 minus 0. So it's 15 divided by 4. We get 3.5 meters per second squared. And see how the units work out? Meters per second divided by second gives us meters per second squared. So the acceleration of the object from 0 to 4 seconds is 3.5 meters per second squared. Part B, solve for the displacement from 4 seconds to 6 seconds. So what's the area between the line and the x-axis? Oh, there it is. It's shaped like a rectangle from 4 to 6 seconds. The base is 2 seconds. The height of the rectangle is 15 meters per second. So the area, or the displacement, will just be the length times the width. 2 seconds times 15 meters per second. Seconds cancel out, and we're left with 30 meters. That's the displacement. Now we need the acceleration from 4 to 6. Well, first of all, what happens to the velocity? It stays the same. So a constant velocity means you have 0 acceleration. So let's just make sure it still works on our graph. We need the slope, which is the rise over run, change in velocity over time. Change in velocity is 0. It stays the same. Divided by 2, well, 0 divided by anything is going to be 0. So we're not accelerating from 4 to 6 seconds. The velocity is constant. The acceleration is 0.